Here we have an improper integral from negative infinity to negative 5. And the reason this is an improper integral is because we have an infinity sign in one of the bounds of the integration. So this is an improper integral. So what we're going to do is we're going to remind ourselves what this actually means. So the integral from negative infinity to negative 5 of 1 over x squared dx. What that actually means is the limit as n goes to negative infinity of the integral from n to negative 5 of 1 over x squared dx. So all I've done here is remind myself what this actual definition is. Instead of having this negative infinity in the bottom, what I have now is n, and then after doing this definite integral, which I can do using my definite integration rules, I then just take the limit as this n goes to negative infinity. Okay, so let's just do that. We're going to keep this limit part here and not really do much with it. And what we're going to do is try to figure out what this definite integration is. So, of course, 1 over x squared is just x to the negative 2, and the antiderivative of x to the negative 2 is just x to the negative 1. And what we're going to do is we're going to evaluate that from n to negative 5. So we'll just keep this limit stuff here for now. And let's actually finish this calculation of the definite integral. We're going to plug in negative 5. We get negative 5 to the negative 1 minus what we get when we stick in n, which is negative n to the negative 1. Okay, and if we simplify that a little bit, we still have this limit as n goes to negative infinity. If we simplify this a little bit, this ends up being positive 1 over 5 plus 1 over n. And as we take the limit as n goes to infinity, this becomes more, the bottom of this fraction becomes larger and larger negative numbers. So negative a million, negative a trillion. And of course, 1 divided by a very large number quickly goes to 0. So as n goes to negative infinity, this goes to 0. And so the answer that we're left with is just 1/5.